All right, hello everyone. I am Rebecca Duell and I will be hosting this Skywarn spotter training online. We still have a few people that are joining us right now, so I'll go ahead and wait another minute or so, and then I'll go ahead and get started. All right, so I have 301 here, so I'm going to go ahead and get started. Hopefully you all can hear me. If you can't, please let me know. If you open up your GoToWebinar panel here, there is a place where you can type in questions. So I'll be monitoring that. It's under a tab that says questions. I'll be monitoring that. If you have any questions throughout the presentation, or if you can't hear me and lose audio or anything, please let me know and I will keep that open. But looks like we still have a couple people joining right now. Let's see. All right. Looks like we got the thumbs up from operations that the audio is working. So I think we're gonna go ahead and get started here. Okay, well, thanks for joining us. Like I said, my name is Rebecca Duell, and I am a meteorologist here at the Weather Service in Burlington. And this is a Skywarn spotter training, and it's kind of more of a supplement to our hydro training that a couple of our meteorologists, Andrea LaRocca and Robert Haynes, did earlier this summer. They did the hydro training in the spring, so if you've seen it, or if you attended that training, great. And if you haven't, I highly encourage you to sign up for that training. It's actually saved on YouTube and you can see it online. But basically what I'm going to show you today is some real world examples for hydro training based on an event that we had about a week ago here in Vermont. The event took place on July 14th. And I'll be doing the flash flooding event review on it today. I also had help from Robert Haynes here at the office as well, compiling this presentation, and he is our Skywarn spotter program leader. So if you are a spotter with us, you're probably familiar with Robert, but he is on night shifts right now, so I'll just be going solo on this presentation today. Okay, let's see. All right. So first of all, what happened on July 14th? So like I said, this was about a week ago. I was working the hydro desk that day, so I can kind of walk you through what we were seeing. I'll keep the meteorology down to a minimum and focus really today on the hydrology aspect of the system. But what ended up happening, as you can see on this map here, this is kind of a map of modeled radar. So this isn't exactly what happened, but this is pretty close to what ended up happening. And I'll show you some radar loops later on. But we ended up having pretty heavy rainfall in parts of eastern Vermont, as you can see. We had what we would call an MCV, which is a mesoscale convective vortex. Big name. If you're not familiar with them, no problem. All it basically means is that it's the circulation of heavy rainfall, and it formed over the Vermont and New Hampshire border. So it was kind of just on our border with the Gray Maine Forecast Office. So the Burlington office, which is ours, we cover up until the Connecticut River. So we take all of eastern Vermont, and then the New Hampshire part was covered by Gray. So this presentation won't focus on the flooding in New Hampshire. That's Gray's area. So if you want, if you have any questions about what happened in New Hampshire, you can, I'm sure, reach out to the Gray office, but we'll be focusing on Vermont today. So we had this mesoscale convective vortex, or this MCV, set up, and we basically had several ingredients for heavy rainfall on this day. It was a really slow moving system. It formed in the morning hours and it just pivoted over our forecast area. And that presented some problems because that meant that the heavy rainfall that was occurring over eastern Vermont, it continued for a long time. So probably at least 4 or 5 hours. In some locations saw heavy rainfall as the system just pivoted. And usually our systems are a little more progressive, so they form, and maybe you have a cold front or something and it sweeps through pretty quickly and it's able to move out of the area pretty quick, so that limits the flooding threat. But when you have a system like this where it's just pivoting overhead, that's a little more of a flooding concern for our area because it's just a longer duration of rainfall. We also had a relatively high moisture content of the atmosphere, so there's several ways we measure it. I think we probably have some meteorologists or some of you may be studying meteorology, so if you're familiar with it, we call it precipitable water. It's basically a fancy name for measuring the content of the rainfall, or sorry, of the precipitation in a column of air. So it's kind of a way that we can figure out how much water could fall. So when you have really high precipitable water atmosphere, that's typical over like the Gulf Coast and places like that. And that means that the water or the system, the air is very moist basically, and you could get heavy rainfall. Well, what ended up happening this day is we got some pretty moist air moving up over our area, and our precipitable water values, they were about 1.5. It's not off the charts high by any means. I think our records, daily records, are around 2 inches to put it in perspective, but it's still a pretty moist air mass for us. And then we also had enough instability to support some embedded thunderstorms, and we'll go over that a little bit later. So I took these next few slides from the Skywarn Hydro Spotter training that I alluded to earlier that Andrea and Robert did in May, but we're just going to go review this real quick because I'm going to touch on this a little bit over the next few slides. So what causes flooding to take place? So basically it's all about balance, and all we're doing is basically trying to measure to the best of our ability how the system is balanced. So basically how much rainfall or water is going into the rivers versus how much is going out of the river system. And it's pretty simple. If you study science or engineering or anything, you'll know that if you know the amount of water that going into the system exceeds the amount of water that's going out of the system, then we have a flooding concern. So basically all we do is just have a bunch of tools that basically estimate how much water is going into the system, and we compare it to how much the system can take, basically. So that's all it is. So the next hour or so, we're just basically going to measure, or I'm just going to show you all these different ways that we use to basically see how the balance of the rivers is. And that's our best way of telling if there's any sort of flooding taking place. So basically, here's what we have on this slide: a river in balance, the schematic on the right. You have water going into a river from tributaries of the river, rain, or snowmelt in the winter, or even into the spring, definitely for the snowmelt. Now for us, for this event on July 14th, snowmelt was not a factor. It was more the heavy rainfall that led to the flooding that we had. And then there are also ways for water to leave a system, and that will be through infiltration, so basically into the nearby soils, stream flow, so getting carried out, and then also evaporation. So the bottom schematic there on the right is a river out of balance, where you have more water going into the river than going out of the river, and that's when you get flooding. And it can be gradual, which is we just call flooding, river flooding, or it can be rapid, which we call flash flooding. And I'm gonna reference flash flooding quite a bit in this presentation here, but basically all I mean by flash flooding is we define it as life-threatening flooding that occurs quickly, usually in less than 6 hours. So the key with flash flooding is that it's occurring very fast, and that can be particularly dangerous because of the fast nature of the flooding. There's several things that can cause flash flooding. We can see flash flooding from dam failures, ice jams, which is a big one here in Vermont in the winter. We do see quite a bit of flash flooding from ice jams, as you all probably know. And then the other main reason that we get flash flooding is from heavy precipitation, which is what happened in this event. So go on to the next slide here. Okay, so I wanted to include this graphic here because all this is basically a picture of a river basin. And over the next few slides, I'm kind of going to superimpose these river and basins onto the map of Vermont, so you can see the different river basins in eastern Vermont, and you can see what tributaries drain into them and things like that. So all it is basically water takes the path of least resistance. So any water that flows into or falls as rain over a basin is going to take the path of least resistance to through the tributaries, usually to the main river channel, and then carried out through the main river channel. So keep this schematic in mind as we go over the next few slides, and I'll show you the river basins, like I said, over eastern Vermont and how they kind of played a role in this flooding event. And in addition, we also look at the topography, which is very important for, especially in our area. When you get steep topography, you tend to get more flash flooding because it runs off faster. We also look at the soil composition, so whether or not the soil can absorb the water or not, and whether the area is urban or rural. So if you have an urban area, it's more prone to flash flooding because there's more concrete and there's less soil able to absorb the water. So these are all different factors that we take into mind when we are looking at flash flooding potential. And here's an example, the role of topography that I briefly touched upon in the previous slide. Steeper terrain is more prone to flash flooding. So this is an example on Google Earth of the terrain around Chelsea, Vermont. You can see that it's kind of in a valley there, and it has a lot of mountains around it. And basically any of the drain off, so any rain that falls in that area is all going to converge onto the Chelsea, Vermont area. So this is just an example of one of the towns in eastern Vermont that is susceptible to flash flooding. So that's something that we look at, especially when we're issuing flash flooding warnings, is it in an area where the topography is going to, send all the water to one area? And that certainly played a part in the July 14th flooding of last week. So, all right. Do you guys have any questions? I will take a quick pause for questions here. If you want to type your questions, it's probably the easiest way. If you, like I said, I'm monitoring the question box, so feel free to type any questions in. So the River Forecast Center, I'm going to use some of the River Forecast Center's graphics here later on, so I want to touch base real quick on what that is. The River Forecast Center is, they basically, there's a number of RFCs throughout the country. As you can see, this is a map of where they all are. And the River Forecast Center close to Boston, it's right outside of Boston. It's in Norton, Massachusetts. That is the River Forecast Center that serves our forecast area. So they produce all sorts of river forecasts in terms of like how much the rivers are going to rise, and also they produce the flash flood guidance, which we'll talk about later. But that's very important for some of our monitoring of hydro rivers. So this is an example of the river forecast that the RFC creates. This is one of ours, just an old one of the East Branch of the Ausable River, which is in eastern New York. But as you can see, it's basically a graph. It progresses in time along the x-axis, as you can see. So this is actually the current time, not today, but as of the time this was taken. But this would be the current time right here, and then the purple is the forecast river level, and the blue is the observed river level, so the river level in the past. And then we're monitoring these all the time for all different rivers. We have river gauges set up throughout our forecast area, but we're monitoring, especially if it gets close to action stage, which is different for each river, what action stage will be, or minor flooding stage. So we're always concerned, if we start to see rivers spiking, it means that the river levels are rising and they may be approaching action stage. As far as what is action stage for each river, that differs. Like I said, it is something that we work with the local emergency managers on to determine what the local basically thresholds for flooding is in their area, and we assign our thresholds with them based on that. So this is just an example of a hydrograph, and I'll be showing you some real-time hydrographs a little bit later. And this is just an example of how the River Forecast Center produces potential future river forecast levels. So the last piece of guidance that we'll be using is flash flood guidance, and this is also produced by the River Forecast Center. So this is, for example, the River Forecast Center in Taunton or Norton's flash flood guidance for us. But basically, all it is, the flash flood guidance, is just the amount of rainfall needed within a certain period of time for small streams to overflow their banks. That's all it is. So basically, this is the key number that we're looking at. It's different for 1 hour versus 3 hour versus 6 hours. But basically, for example, all the 1 hour flash flood guidance is the River Forecast Center takes into account the soil moisture, recent rainfall, whether there's snow in the area, all kinds of different factors, and they put out these maps every day, multiple times a day. And all it is basically if this area sees more than this rainfall in a 1 hour period, then there's probably going to be some flash flooding, or essentially small streams will overflow their banks is, I think, the official definition. So these are kind of the key numbers. So we'll take a look at the flash flood guidance for July 14th here. This is the 1 hour flash flood guidance for July 14th. And the area of concern where we had most of our rainfall is this eastern Vermont area. So you'll see Orange County, Vermont, and Caledonia County, Vermont, and into Washington County, Vermont. So for most of this area, our flash flood guidance is kind of in the green to yellow to maybe the orange. So we're looking at flash flood guidance generally around 1.5 inches to about 2.5 inches. So that's kind of a key number that I'm keeping in mind when I'm looking at how much rainfall they've gotten. So if they've gotten more than around 2.5 inches, then I start to get concerned about flash flooding in their areas. And then we also have 3 hour flash flood guidance, which, as you can imagine, a little bit longer duration, which means that the rivers can take a little bit more water before flash flooding. So our flash flood guidance is now for 3 hours, anywhere between about 2 and about 3 inches. So basically the magic number for the 3 hours is about 2 to 3 inches of rainfall before we would be concerned about flash flooding. And then lastly, we'll look at the 6 hour flash flood guidance. So this is a little bit higher. So we're looking at right around 3 inches for the area of concern. So basically, if this area sees more than about 3 inches of rainfall in 6 hours, then we're going to be concerned about flash flooding. So all we're going to do next is basically keep that flash flood guidance in our head and then use some different tools to look at the radar and see whether or not we met those thresholds for flash flooding. So the first area of focus, there's going to be 2 case studies I'm going to look at today. Both happened on the 14th of July. The first area of focus on the left, you can see the map of Vermont here, and this is the area that I'm zoomed in on, but it's mainly Orange County, Vermont, into southern Caledonia County and into eastern Washington County. You can see this bigger map is zoomed in on the right. So what I have here is the rivers in blue, as you can see. So this river right here is the Wells River. That's one of the rivers we were concerned about on this day and we were monitoring. And the other river that we're monitoring closely is the Waits River. So both of these are in eastern Vermont. You can see here's the Waits River that my cursor is over right here. And they're both labeled so you can see them. And then they both the Wells River and the Waits River flow into the larger Connecticut River, which obviously forms the boundary with New Hampshire. So to the right of the Connecticut River is New Hampshire. And once again, like I said, our forecast area only goes up until the Connecticut River. So these are smaller rivers, the Waits River, the Wells River, they're smaller. The Connecticut River is quite large. So basically the Connecticut River can take a lot more rainfall without flooding than a smaller river like the Waits River or the Wells River. And then the only other thing I want to point out on these maps, just to get our kind of spatial recognition here, is this red outline right here. This is the river basin. So this is basically all the rainfall that falls within this little red shape here will flow into the Wells River. And then same thing for the basin further south. So all the rainfall that flows into, or all the rainfall that falls over this red outlined area here will flow into the Waits River and then into the Connecticut River. So basically, we are concerned with the amount of rainfall that's falling into each individual basin. So that's what we're going to be monitoring. So we're going to keep those basins and the rivers and everything labeled. And we're going to go to the next slide here. And we're zooming out a little bit. And this is the radar loop. So you can see a few things to point out. First off, here's our basin for the Waits River right here. So this is the area we're looking at. And then our basin for the Wells River, a little bit further north. So these are the 2 areas. And then this is the radar imagery for that day. So as you can see, this system, it kind of rotated right over eastern Vermont right here. And there was just a continuous period of rainfall. And this was pretty heavy rainfall. Even as the system's lifting through New Hampshire to the east, it's still falling. Rain is still falling over eastern Vermont. So this is kind of the behavior of the system. So we were concerned on this day as we saw that behavior. Initially, there was this heavier precipitation with the red on the radar, and then it just pivoted over the same area for about 6 hours or longer for that area. So that's the radar imagery of what happened. So I'll let this finish running through, then we'll go on to the next slide. And as you can see, still, even towards the late morning, it's still over that area. All right. So next, what we have to do is estimate how much rainfall fell. And sometimes that can be hard. If you live in Vermont, especially if you live in eastern Vermont or into New Hampshire, you'll know that radar coverage in our area is not good in eastern Vermont. So you really can't see what's going on in the low levels because the radar is actually in the Champlain Valley and it's blocked by the Green Mountains in the low levels. So it's very hard to see exactly what's going on. Same thing with, there's another radar by the Gray office, so close to Portland, Maine, there's another radar, but that's also blocked as it points northeastward through the White Mountains in New Hampshire. So again, no radar has a really good view in the low levels of the Connecticut River Valley. So that is kind of a real challenge for us, is to see how much precipitation has fallen in a day. And that's actually where we really do rely on our spotters to come in, because the spotters provide that ground truth that we don't have, especially in that area. So what you're looking at right now is a 6-hour accumulation estimate. It loops through quite fast here, actually, but this is the area of concern. This is the Connecticut River right here, and where you see these yellows into these reds, that's where it's estimating over 3 inches of rainfall falling in 6 hours. So this is where we really had that area for concern. So it was kind of in a swath from Fairleigh, Vermont, up until around the South Reigate area of Vermont. So a lot of the rain fell pretty close to the Connecticut River. And if you recall earlier, the Connecticut River is a larger river and it can take a lot more rainfall, but we still were quite concerned about the Waits River here and also about the Wells River here, as some of the heavier rainfall was falling in these areas. In addition, around 6 or 7 a.m. that morning, we did have reports in Woodsville, New Hampshire, so not in our forecast area, but just across the border. Woodsville's right here, of some flooding in their area. So we're seeing several factors that are kind of like piquing our interest here, and we're a little concerned about flooding. First off, they're getting 3 inches plus of rainfall over 6 hours. And if you remember the flash flood guidance we looked at earlier, that was kind of the magic threshold. We said about 3 inches in 6 hours. So at this point, this estimate is estimating that they are exceeding what the area can take before they get some flooding. So the radar estimates are suggesting there's potential for flooding, and then we get the ground truth in Woodsville that there is some flooding occurring on the New Hampshire side of the border. We did not hear anything at this point about any sort of flooding or anything going on in eastern Vermont, but we were getting a few reports, mainly online, but of about 4 inches of rain, mainly just north of Fairleigh areas where we saw some of the reports here. So that's the only ground truth we had to go on that day. But based on this data, we did go ahead and issue flash flood warnings in eastern Orange County on that day. And the flash flood warnings covered Orange County into Caledonia County and went right up until the border. And then Gray, Maine did have flash flood warnings out across the border in their forecast area as well. So we kind of had that area of the Connecticut River Valley covered in flash flood warnings that morning. This is something pretty cool. This is one of the tools that we looked at in real time that we use. It is flash flood guidance ratio. So all it is it's taking the ratio of the estimated precipitation from the radar, so what that loop was on the previous slide, so we said about 3 inches in 6 hours. It's taking that estimate and then it's comparing it to the flash flood guidance from the River Forecast Center that we looked at earlier. So this is kind of we're doing that math in our head, kind of keeping in mind the magic threshold of, 3 inches per 6 hours. But this is something that actually calculates it on our screen for us. And it's really useful. It's a newer tool, but it's proved really useful so far. You can see the yellow here and the red is actually, the legend is really small. So I'll give you the numbers, but basically right where the yellow pixels start is where it's calculating about 100% of flash flood guidance has been met. So basically it's calculating that the amount of rainfall is equal in those areas to the flash flood guidance. So anything darker than that, so the darker yellows into the oranges, into the reds especially, is suggesting that flash flood criteria has probably been met. Of course, this is all based on estimates from the radar. So again, that's the best we can do in the area, and that's where our spotters come in. So if we have any spotters in the area, we would be calling them at this point, seeing what kinds of rainfall they're getting and if they're seeing any flash flooding. We were doing that the morning of actually, and we called several towns around the Connecticut River Valley area. We didn't have any reports at that point of flash flood warnings or flash flooding concerns. It's just a lot of heavy rainfall, but we did keep the flash flood warnings up just based on those amounts of rainfall that we were getting. So I'll let this loop through one more time here, and you can see, so where it's the red is where it's close to about 200%. So they've gotten about twice the amount of rainfall that the flash flood guidance estimate that they would be able to take. So we're pretty confident in those areas that we have cause for concern, and that's, of course, was included in the flash flood warning. The next little loop that I have is something newer as well. You may have seen these, actually. I've seen they've started showing them on TV sometimes during flash floods. Maybe some stations do, I'm not sure. But if you ever see it, this is called Precipitation Accumulation Return Period. And all it is it is a map of the return period. So basically, it's just the amount of time in years that you would expect to go between rainfall amounts of this magnitude. So the red here, the legend's really small up here, but it's about 10 years. So anytime you see the red, it's what the radar is estimating about 10-year rainfall amounts. So basically they would only see these rainfall amounts in this area about once every 10 years on average. The purple would be closer to 40 or even 50 years. So this is just kind of another way of putting it into context for us to know that, they're getting 3-4+ inches of rain in 6 hours, and this is pretty rare for this area. In approaching 1 in 50-year flooding, potentially. Again, this is all just estimates off of the radar, but what we were seeing based on several reports of around 4 inches and the radar, we figured these amounts were pretty accurate. So that's also something that we look at in real time. And actually, when we're working operations in the office, we have all of these up on a screen at one time. So we'll have like a panel up with the radar, we'll have a panel up with the accumulation return period, we'll have a panel up with the precipitation estimates from the radar. So we'll have kind of all these different things that we're monitoring. Of course, like I keep saying, the main thing we're missing in the office is ground truth. So if you're ever getting very heavy rainfall in your area, we really would appreciate a call to know just how much rainfall you've gotten. Especially if it's exceeding 2 or 3 inches in an hour, that's something we definitely want to know about. And that's something we would probably, well, I'm sure we would be watching it on radar, but it would be really good to have the ground truth to know that what's actually happening at the surface is what we're measuring on radar. So really quick, I'm just going to go over the river conditions once again. This is an example of a hydrograph. So we'll go ahead and look at the hydrographs on this particular day. So all these are just river gauges. We have several river gauges throughout our forecast area, and they report water levels and stream discharge at regular intervals, and we can watch them, and we do watch them at our office, and you can also pull them up online. They're available to the public, these hydrographs, and this is an example of one in Otter Creek. So there's Otter Creek there, the upstream of the river gauge at Center Rutland. So for this area, the Wells River, we have one gauge at the bottom of the Wells River, so close to the Connecticut River. And on the Waits River, we only have one gauge, but it's at the very top. So this is basically our way of measuring what these rivers are doing and if there's flooding along these rivers. So the first one we saw, this is the East Orange branch of the Waits River. It's at this first triangle here that the arrow points to. And this is this little peak here that you see on the 14th. This is in response, this rise is in response to all that rainfall. So as you can see, they started out at about 1.5 feet, and then they got all that rainfall and the river rose to about 2.25, 2.25 feet. So we saw a rise of about 3/4 of a foot on this river. Now keep in mind, this is at the top of the river. The rivers flow in this area from west to east. So we expect if we had a gauge down further towards Bradford area, we would expect downstream to see a higher rise because you would have all the rain from all these little tributaries going through Topsham, Corinth, all these areas. You would have the water compounding at the bottom of the Waits River, kind of sort of in the Bradford area. So sure enough, we had a similar thing in the Waits River. We actually have a gauge at the bottom of the Waits River. And as you can see, the rise was quite a bit more substantial at the bottom of the river. So, or sorry, the Wells River, I'm sorry. This is the gauge at the bottom of the Wells River, and the rise was pretty substantial there. So we started off just over 1.5 feet, and then we rose pretty sharply the morning of July 14th, and we peaked out at about 3.5 feet. So that was a pretty substantial rise, almost 2 feet. But the good news for us and the area is that that was still well under any sort of minor flooding, which would be this orange up here, or action criteria. So at least the rivers were not flooding, but we were, and these are just kind of the main stem rivers, but we were definitely concerned about flooding on some of the smaller rivers around the area, especially with the precipitation amounts we were getting. But this is just an example of how we monitored the river gauges in real time. So what ended up happening in Orange County? So we had, like I said, some unofficial reports of around 4 inches of rain near Fairleigh, Vermont. Otherwise, we didn't have any verification in this area, which is a good thing. So we didn't have any reports of flooding or damage, which is good. And it's likely in this case, since the Connecticut River is such a big basin, that most of the water went into the Connecticut River, and it was able to take the water and the amount of rain that fell in the area, which is pretty impressive because a lot of rain fell in the area. But maybe we just don't know. Maybe there are some washouts or anything. But if you are in the Orange County area, then we and you did see of any sort of rivers flooding, we'd love to hear about it. But I do have a question here. All right, let me go ahead, and it's been a few slides back, so I'm going to go back here. All right, the question is, let me see if I can make it bigger here. What technology did you use to make those maps with the river basins outlined in red? The technology for these it's on our machines that we have, so it's something that has been mapped out ahead of time in our forecast area by hydrologists who have basically taken into account the topography and looked at where all of the tributaries flow in our area. And we overlay it with our AWIPS machines here, and we actually have some of our hydro focal points here in our office, so I can bring them in at the end of the presentation. They can talk a little bit more about what goes into these making these river basins. But basically, these river basins are they don't change for our forecast area very often. So we just have them outlined, and generally when we're monitoring rainfall and when we're monitoring radar, we do have these basins up just so we have an idea of which basin the rainfall in a certain area will flow to. All right, so we'll keep going. Any other questions for the first flooding in the Orange County area? Anybody in Orange County and experienced that rainfall and saw anything? All right. Nothing heard, so we'll keep going. Next, we're going to switch gears and move a little bit further north into the Northeast Kingdom. So we're going to be focusing on flash flooding that occurred on the same day, same system, in Cabot, Danville, and St. Johnsbury, Vermont. And what happened with these areas was we had embedded thunderstorms. So not only do they already have that prolonged period of rainfall as the mesoscale convective vortex pivoted over the area, but they also had thunderstorms. So the thunderstorms were able to get even heavier rainfall rates. So they had both the long duration of rainfall, plus the thunderstorms making very heavy rainfall precipitation rates. So we look at both the duration of rainfall and the rate of rainfall when we look for flooding. So both those were pretty impressive in these areas. So here's the basin that we're switching to. So we're switching a little bit further north. Here, down here is the basins that we were looking at before, as you can see. So now we're into Caledonia County, Vermont. So I actually have the counties outlined here in orange. This is Caledonia County, Vermont. So this is northeastern Vermont. Over to the west here, this is the northeastern part of Washington County, Vermont. So the basins we're going to be looking at on this one is the Passumpsie. So the Passumpsie is the main one for Caledonia County, and it has a whole bunch of tributaries. This is the Passumpsie River here, and it drains into the Connecticut River just south of St. Johnsbury. And there's a whole bunch of tributaries that go into the Passumpsie, which basically, and there's a lot of topography in this area. If you've ever been out to the Northeast Kingdom, I'm sure there's some of you guys probably live out here. But you'll know that the area does tend to flood pretty easily, especially because of the topography. St. Johnsbury is topographically in an area that's the confluence of a bunch of different valleys. So there's definitely a flash flooding threat. And we do tend to see the rivers respond pretty quickly in St. Johnsbury and in Lyndonville, a little bit further north, anytime we get heavy rainfall over the area. So we're going to be focusing on that basin this time. We're also going to be focusing a little bit further west in over Cabot. As you can see right here, Cabot is in northeastern Washington County, Vermont, and it actually lies right on the headwaters of the Winooski River. So this is the Winooski River that drains all the way to the west into the Champlain, into Lake Champlain. So actually this river right here is draining from north to south in this area. So all the rain that falls in this area is going to drain into the Winooski for this area. So these are the two basins that we're going to be looking at for the next part. All right, here's our radar loop. Cabot is this star right here. St. Johnsbury is the other one, so you can see where they are. And I also have our flash flood warnings as they were issued, put in green, these little polygons around them. So a lot going on here. This is our area, like I said, that we're looking at. You'll see initially, once we get back to the beginning of the loop, you'll see some pretty heavy thunderstorms, first of all, develop over Cabot. So here's area of thunderstorms just east of Cabot, and then right here is where we started to get concerned. This was early in the morning, and then we issued a flash flood warning. Same thing later, thunderstorms developed in St. Johnsbury, and they started training over that area, which basically means we kept having thunderstorms move over the same area, and we issued another flash flood warning for St. Johnsbury. So those were the two other flash flood warnings that were issued on this day, Cabot and St. Johnsbury. So we'll go ahead and look at some of the same things that we were looking at on the previous for the Orange County areas. We'll look at that now for a little bit further north. So I'll just let this loop finish one more time. But it is very interesting how just continuously, especially in Cabot, the same area just sat under thunderstorms that were just regenerating throughout the morning. And the rain rates were very impressive there, especially. So, and Danville here in between St. Johnsbury and Cabot, that will be referenced a little bit later too, but we did have some reports in Danville as well. So, all right, so now we're going to look at our 1 hour precipitation estimates. So you'll probably remember the previous little case study that we looked at in Eastern Orange County. We looked at 6 hour precipitation estimates. This one, we're actually changing gears. We're going to look a little bit shorter duration at 1 hour precipitation estimates because these were more thunderstorms. So we're actually going to be comparing these amounts that fall now with our 1 hour flash flood guidance. So these are things that we're always keeping in mind. We're looking at our 1 hour precip rates and how that compares to our 1 hour guidance, and then our 3 hour and our 6 hours. So we're looking at them all. But for these thunderstorms, it was the 1 hour precipitation estimates that really stood out to us. So again, this is the estimated precipitation in 1 hour. So we'll focus on Cabot first. So here's Cabot right here, and we'll focus on it. And we'll start to see the light blues, which are around 1/2 inch, greens are around 1 inch, pink around 1.5 inches in an hour. And now we start to see the dark blue, which is estimates of around 2 inches in an hour right over Cabot, as you can see. And then we started getting heavy thunderstorms after that over Lyndonville. So we started getting 1.5 inches, 2 inches over Lyndonville per hour as well. And that was also a bigger cause for concern. So here's the 2 inches over Lyndonville. This dark blue is the 2 inch per hour. So that's kind of a good threshold. So basically we had the thunderstorms first form over Cabot, and then additional thunderstorms form just north of St. Johnsbury, kind of in between Lyndonville and St. Johnsbury. So initially we were concerned about the Cabot system, and then we went on after that flash flood warning was issued. We then kind of became alerted to the Lyndonville issue. And I think this is the exact product I was using the day when we issued the flash flood warnings. I think we were using this estimate here, and we were also looking at this next one, which is again the 1 hour flash flood guidance ratio. So this is the same stuff that we were looking at for the previous event. This is basically how close we get to the flash flood guidance. And again, the key for these, again, the legend is very small, unfortunately, on our machines. But when you're looking at the yellow pixels, that's about when we're right at 100% of flash flood guidance. So that means, again, that our estimates for our rainfall is about equal to what the flash flood guidance is. So then we start to be concerned when we see the yellow, and then the darker yellow into the orange is when we start to exceed the amount of rainfall for flash flooding. So that's when we would start to get concerned. So we'll let this start from the beginning again here shortly and focus on Cabot first. Here we go. So here's initially the morning system forming over Cabot. We're starting to get some yellows, we're starting to get concerned. This is about when the flash flood warning was issued. And you can see it just sat over the Cabot area. And then to the east, we started getting concerned about this stuff going up pretty quick by Lyndonville. And then we saw the system move a little bit to the southwest in between Lyndonville and St. Johnsbury. And I think right about now is when we issued the flash flood warning for that one. And sure enough, the yellow pixels where we started getting about 100 to 150% of flash flood guidance being exceeded in that area. So that's something else we were using there. Another thing, Cabot's topography. Cabot is kind of in a bowl. This is an idea of the topography, but as you can see, the valley here, all the areas rainfall would drain into Cabot. So that was another reason we were concerned, knowing the topography of the area. So that's something else we're always keeping in mind. Look at the river gauges in these areas. First off, there aren't that many river gauges, and that, like I said, is another reason why we really do need the spotters, because a lot of times where we want a river gauge, there may not be one. But what we did have was a couple river gauges along this branch here in North Danville here, which was a tributary into the Passumpsie. So you'll remember the heavier precip fell kind of first in Cabot, which is around here, and then it kind of meandered over here. So it's kind of this whole area was the area we were concerned with the most. So the only 2 gauges that we have in that area to measure the stream levels are along this tributary in North Danville. So we'll go ahead and look at those. So North Danville, it's called Pope Brook. This is at kind of the head of the tributary here, but you can see a very sharp spike from about a 1/2 foot, which was the level of the river before the rain, and then it quickly went up to just under 2 feet, so just under 1.5 feet within an hour or two rise on the river. So, and keeping in mind that was at the head of the river, this tributary flows from west to east down into the Passumpsie, and then the Passumpsie flows from north to south towards the Connecticut. So a very sharp rise, and of course we would estimate that this would be even sharper rise as we go downstream. So, and sure enough, this is the another hydrograph that we have a little bit downriver here, closer to St. Johnsbury, but you can see a rise from just under a foot before the rain to about just under 3 feet after the rain, really quick in this time span of about an hour or two again. So that was a really quick rise as well, and that was just about 2 feet rise. Once again, our rivers are running really low here in Vermont, especially before this rainfall. We were in a drought for parts of our forecast area. So that was the good thing, is that we weren't running high. If the rivers were running very high before this and had those rises, then we would have probably had more river flooding. But luckily our rivers were very low and they were at least able to absorb the amount of rain. Despite the rise, we didn't really come too close to any sort of action criteria for the rivers. But we were still concerned about flash flooding along, washing out roads and things like that, which is why the warnings were issued. So what ended up happening, let me go back. This is one of the models. If we have any kind of weather nerds out here, you're probably familiar with the HREF. It's one of the models we use to basically look at heavy rain chances. Before the event, the chances were non-zero of heavy rain, but they were very low. So the threat for rain was anticipated to be from convection in the afternoon, not necessarily in the morning. So this was earlier than what we thought the threat would be. And then as we went on, this is the 5 a.m. forecast from this model, and the 8 a.m. forecast is on the lower left panel. And this one, as you can see, is a little bit higher chances of heavy rain or higher probabilities of heavy rain. And then by 2 p.m. that day, the model had really caught on with the heavy rainfall over our forecast area. So this was one that the models definitely struggled with. They really struggled with the MCV forming that morning, which obviously led to our concerns in Vermont. So this was a tricky one for all of us. So what ended up happening in these towns that we were looking at, heavy rain was reported at both Cabot and St. Johnsbury. We had reports of around 3 to 4 inches of rain total in these areas. So we had several spotters who did call in. So that was very helpful that we had spotters in those areas. So we had a lot more ground truth in this area. We ended up getting reports of several roads washed out in Cabot, Danville, and in St. Johnsbury. So kind of all on that swath of heaviest precipitation, we did end up getting road washouts in that area. And of course, anytime you do get 3-4+ inches of rain, that's pretty common that you're going to get something. There was also a mudslide reported in St. Johnsbury near the mall, and that was a result of the heavy rain that the area had received earlier that morning. So we did have several impacts to the Northeast Kingdom area with this. So that concludes the presentation. Thank you all for joining us today. Looks like, yeah, okay, we kept it under an hour. So if you have any more questions, I will be happy to answer them. You can type them in the question tab here, or you can raise your hand and I will unmute you if you wanted to ask it over, over the webinar, you can do that. So, all right, so I will leave it open now if you have any questions, like I said. If not, thank you very much for joining us. We really appreciate it. Like I said, if you have not yet seen the Skywarn talk or the Hydro talk that was put out earlier this summer by Robert and Andrea, I highly recommend you check it out online. We have the links to that on our social media pages. Actually, on the advertisement for this, I have the links to that Hydro talk, which you should be able to find. If not, you can go to our NWS Burlington YouTube channel, and then you can search for the Skywarn Hydro talk, and you can find it there as well. So thanks all for your time. I don't see any questions right now, but I'll stay on the line a little bit longer. And if you guys have any questions, please feel free. Otherwise, have a wonderful day. All right, good question. All right, did you have any correspondence with local emergency management agencies during this event? What types of information did they ask for? All right, yes, absolutely. That is something that we are doing throughout the event. When we are getting any sort of heavy rainfall like this, we are definitely talking to emergency managers. In this event, we specifically were in coordination with VEM, so Vermont Emergency Management. We were in close coordination with them over the phone. We oftentimes during events like these, we will closely talk with VEM, especially if we get any reports of flooding, or if they have any reports of flooding, they'll immediately pass them on to us, or we'll pass them on to them. On this particular day, we were in contact with VEM multiple times. Like I said, they called. We hadn't had any reports of flooding at that point, and they were monitoring their sources as well, and they hadn't had any, but we were definitely in contact throughout this with Vermont Emergency Management. In addition, we also do call most of the fire departments in those areas. So throughout the event, we were trying to get ground truth in Eastern Orange County, and then again, of course, in St. Johnsbury, Lyndonville area, and then in Washington County. So we were calling fire departments from all those areas and local police departments in those areas, and we did have some great help from them. And a lot of times they were able to tell us, nope, we haven't had any reports of anything, and that's great, and that's good. That's what we want to hear. And that also helps us to know that there are no concerns in the area. But then we were also able to get the reports of the road washouts from fire departments in Lyndonville, St. Johnsbury, and Cabot are the ones that, and spotters also. Spotters told us about the road washouts in Cabot as well. So yeah, several different emergency management members were coordinated with throughout the event. And let's see, what types of information did they ask for? Mainly the information that the emergency managers ask for from us is, have you had any reports? So they want to get a status on where everything is. And then of course they want to know what's upcoming. So they want to know, is the heaviest rain over, or when do you expect the heaviest rainfall to be? How much longer do you think this is going to last for? And also additional rainfall amounts would be something that definitely we would share with emergency managers. So these are all, this is all information that they would use then to make their emergency management decisions. So basically a synopsis of what's happened so far, and then what we foresee in the immediate future, all sorts of information that they may need to make whatever decisions they need to make is what we would do. Thank you for the questions. Let's see if there's anything else. Don't see any other questions. I'm going to stay on the line a little bit longer. You know how basins are created? No problem here. The flash flood basin, yeah, they're free. Well, years ago we edited them, but I think, I'm not sure how they originally created. It's just based on topography and stuff. Yeah, I'm not sure. Yeah, I just, for the question on the river basins earlier that we got, I just touched base with our hydrofocal point, and yeah, they were created about 10 years ago at our office based on topography, and we reevaluate every few years whether or not we need to change a basin or not, but that is something that's generally done through the hydrofocal point, and like I said, it is based on topography. All right, I'll go ahead and end the presentation. Thank you all so much.